Hello, this is Divya Lama. I'm a student. I'm pursuing integrated BSc B.Ed course in physics from Tezpur University. Today, I'm going to give a short presentation on work energy theorem and forces, which is on the basis of conservation. So, the work energy theorem means the relationship between work and energy. We basically know that work is the product of force and displacement, and energy is a capacity to do work which are in the form of kinetic or potential energy. So let us see the relationship between them. Work energy theorem in one dimension. In this theorem, it states that the amount of work done on a body by a force is equal to the change in kinetic energy of the body due to the force act upon it. That is, work done is equal to final kinetic energy minus initial kinetic energy, which is equal to change in kinetic energy. This theorem states that the amount of work done on a body is equal to the change in kinetic energy of the body because of the applied force. Let's prove this theorem. To prove the theorem, let us take a body of mass m, here m, which goes from point A to point B, from point A to point B. Let its velocity be u at point A. So let the velocity be u at point A, and v at point B, and take v at point B. The distance between point A and point B is s. So let's take the distance between them is s. Then the work done on the body in displacing small distance dx. So the work done in, by a body in displacing the small distance, this dx distance, under force F. So under force, this is F, will be dw is equal to f dx. So the work done will be dw is equal to f dx, that is work is equal to force into displacement. So since it has traveled a small distance, we have to calculate the work which is traveling from point A to point B with distance s. So we have to integrate this small work done from point A to point B to get that total work done. So also here the initial kinetic energy at point A is half mu square, and the final kinetic energy at B is half mv square. So let us integrate this small work done to get a total work done. So on integration we get w is equal to integration of f dx. Let us take this equation 1. We know from Newton's second law of motion that F is equal to ma. Force is equal to mass into acceleration. We also know that dv by dt, which means the derivation of velocity with respect to t gives us acceleration. So we put the value of a as dv by dt, and we also multiply dx. It is multiplied because to arranged in the next line. So f is equal to m dv by dx. Here we replace the dt with dx. We got dv by dx into dx by dt. So f is equal to m dv by dx, and dx by dt changes to v because we know that and derivation of x with respect to t gives us velocity. Because of this it changed to b, and which is equal to mv dv by dx. So now by putting the value of f in equation 1, the equation 1 was this work is equal to integration of f dx. So let us put the value of f in this equation 1. Put in the f in equation 1, we get w is equal to integration of mv dv by dx into dx. So here dx got cancelled and we get integration of mv dv, which is equal to integration of v dv, where the upper limit is v and lower limit is u. Here v it implies the final velocity and u implies the initial velocity. Integrating this, we get v square by 2. W is equal to m v square by u with upper limit b by u. We got this value by integrating this term, which is equal to m v square minus u square by 2. So we get W is equal to half mv square minus half mu square, which is a final kinetic energy and which is initial kinetic energy. This says that work done is equal to change in kinetic energy. Hence proved. So let us discuss shortly on force, which is based on the basis of conservation. So on the basis of conservation, force is divided into two types. That is, number one, there is conservative force and the other is non-conservative force. So what is conservative force? Conservative force is a force with the property that the total work done is independent of the path taken. Means this force does not depend on path. For example, the gravitational force, electrostatic force, elastic force. And let us take Earth's surface and a body of mass m is here at height, and take height as h. So if the body of mass moves from here this path and reaches here, or it moves from path this direction and reaches there, along every path the force will be F is equal to mg, and the potential energy at this point will be mgh. Hence it seems that this force does not depends on any path, whether it has gone from this side or this side, the force will be mg and the potential energy will be mg8. So this is conservative force, whereas non-conservative force is a force with the property that the total work done is dependent of the path taken. Means this force depends on path. For example, it is normal force, frictional force, tension, etc. This friction, value of frictional force depends on path. That is, if we take a point A here and a point B here, if a body of mass m moves from A to B with direction in this path, and if it moves from this path or it moves from this path, let's give the path name as 1, path name 2 and path name 3. So here the value of frictional force applied on path 1 will be different from path 2, and which is also different from and 3, and path 3 also different from the both 1 and 2. This is a non-conservative force.